So we're going to take a look at circles again, writing them in standard form, but particularly we're going to be using the process of completing the square in the long run in order to find the center radius form. So we're going to do a quick review, get into using the distance formula in order to write equations, and then follow up with completing the square. Okay, so here are the objectives, pretty similar to what I've already stated. Identify the center of a circle from standard form, which you can do at this point in time. Identify the radius from a circle in standard form. Graph a circle from standard form. Use the distance formula to find a radius, which you're pretty comfortable with at this point in time also. Determine the equation of the image of a circle. So we've been dealing with transformations all along, so that's right up our alley. And complete the square. Those are the three extra things that we are going to address today. Okay, so the standard form, which you should already know, is x minus h square plus y minus k square is equal to the radius square. And if 0, 0 is the center, it's x square plus y square is equal to r square. Okay, so here are some pictures. All we have to do is identify the center. So as you can see, it's at the point 0, 0, also known as the origin. And all I have to do is count the number of boxes going out in 4 spots. 1, 2, 3, 4, and it's the same constant. The radius is equal to 2. So now we want to write the equation. It's x squared, given that the center is 0, 0, plus y squared is equal to 4 because we're going to square the radius of 2. For the next one, the center of the circle is stationed at 2, 1. If I count out, up, to the left, and down, I get the same constant of 3 for my radius. So the equation is x minus 2 squared plus y minus 1 squared is equal to 9. Just in case for those of you who didn't follow along how I got the radius. I'm counting boxes from the center to all these points that I'm designating on the circle. There's 4. Okay, now we're going to go backwards. From an equation, I need to identify the center and the radius. So all I have to do, it's in standard form, it's minus 2 and minus 3, so I'm just going to put positive 2, comma 3 as the center, and the square root of 49. Is equal to the radius of 7. See how there's plus signs here? That means I'm going to have to change the signs to a negative 4, negative 6. Radius is equal to the square root of 36. So negative 4, negative 6 goes here, and the square root of 36 is a radius of 6. Here I keep the 7, negative 5. Square root of 100 is my radius, so I get 10. See, very simple. Okay, going down through the pike here, I have a negative 3, positive 2, square root of 9 as my radius, so that gives me a radius of 3. Center as negative 3, 2. Okay, so here I have 0, comma 2, and the square root of 9, radius of 3, 0, 2 as my center. And here I have a negative 4, 0, square root of 4 is my radius, so radius is indeed 2, and the center is negative 4, 0. Moving right along, I see this, the center is at the origin, and the square root of 1 is the radius of 1. And here I have it in standard form minus h, so I'm going to keep the 4, make that a negative 2, and the radius is the square root of 17. That does not simplify, so we are going to leave that as the square root of 17 and keep the center as 4, -2. Okay, so for whatever reason, when I downloaded the PowerPoint into this medium that we're watching, it did not take the exponents and write them in a superscript way. So I did that up above, just in case you're not paying attention well enough. So make sure that you're reading it correctly. And I think that on your PowerPoint copy that you're taking the notes on, they should be correct. Okay, so we are going to identify from this equation the center. We know that to be 0, 0. And the radius is the square root of 100. So that's a 10. So I'm going to mark my center, and I'm going to go out 10. I don't have enough room to count out 10. You might have enough room, and of course you could always expand your Cartesian plane. I cannot do that at this point, so I'm going to increment by 2's. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, and you could always do that as well. And this will work quite nicely. Okay, so you should definitely use a compass when you construct this. I am unable to do that, so I will do the best that I can freehand. And there's the circle. Okay, center is 2, 4. Radius is the square root of 64, so that's a positive 8. I'm not sure if I'm going to have enough room on here, but I'll do the best that I can. I'm going to increment for increment by 2. Okay, label my center and go out 8. So 2, 4, 6, 8. Don't forget that you incremented by 2 if you followed my method. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Again, you construct with your compass. Never do it freehand as I am doing it. There's the circle. Not too shabby if you ask me. Okay, center is, hopefully you guessed it to be 2, -4 as an educated guess. And the radius, yes, 4. So I can increment by 1. I should have enough room to do this. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Maybe not. Well, I'm going to extend my Cartesian plane this time. Okay, so 2, -4 is about here. And I have to go out 4, 1, 2, 3, 4. Go up 4, 1, 2, 3, 4. To the left 4, 1, 2, 3, 4. And down 4, 1, 2, 3. And 4 would probably be about here. Okay, and you would use your ruler to do that because you would have those items. And construct with a compass the circle. There we go. Very simple. Okay, center. Since I have both plus signs there, they're going to be negative written for my center. And the radius is the square root of 25, so that is 5. Okay, there's the center. Go out 5, 1, 2, 3, 4, 5. Go up 5, 1, 2, 3, 4, 5. To the left, 1, 2, 3, 4, 5, linearly, and down linearly. 1, 2, 3, 4, and 5 would be about here. Okay, again, construct a circle using the center, the point of the compass as the center. Extend out and connect all the dots. Okay, now we want to write the standard equation of a circle with a given center and it passes through a point. So that changes things up a little bit. So since we know the center, we can start to write the equation. So x minus 3 square plus y minus 2 square. And now we just have to figure out the r square. And in order to do that, that's going to represent the radius, obviously. And when you have a center extending out to a point that's on the circle, that's going to contain the radius, or those points are on the radius. So the way in which to find the distance of the radius is to use the distance formula. You've got 2 points. It extends from the center out to the end point, which is a point on the circle. So instead of d is equal to, I'm going to put r is equal to the square root of the change of x, 3 minus the -1 square, plus the change of y, 2 minus 1 square, so 4 squares equal to 16, plus 1 square is equal to 1. That's equal to the square root of 17. So that's the value of my radius. Now if I square the radius, that's equal to just 17. So this is the final output for the equation of the circle, given a point on the circle and the center. In this case, you're asked to write the equation of the circle whose diameter has these endpoints. So you are not given the center. You are going to have to find the center, and in order to do that, you're going to use the midpoint formula along with the other things we just used in the last slide. So we already know we're going to have to use the distance formula, but I'm going to have to find the midpoint first, the center of the circle. And the formula goes like this. You're going to take the sum of the x values and take 1/2 of that, and take the sum of the y values and take 1/2 of that, and that's going to give you the coordinate of the center. So here are my x values. 5 plus a -1 is 5 minus 1 divided in half, comma. 8 plus 2 divided in half. And my new coordinate, 5 minus 1 is 4 divided in half is 2. And 8 plus 2 is 10 divided in half is 5. This is the center of my circle. Using this value, the center, and any of these 2 points, I'm going to go with the positive one. I'm going to plug it into the distance formula, replacing d with an r. So the change of the x values, 5 minus 2, plus the change in the y values, 8 minus 5, square, do the math. Okay, so using the center and the radius, we're going to plug this into the equation in standard form. X minus 2 square plus y minus 5 square is equal to 18. You have to square the square root of 18, which gives you just 18. So how do we find the equation of the image of a circle? So as you can see, we're given a translation. And this should say x plus 4 square plus y minus 3 square. It's not times 2. So the center of the circle is a -4, comma 3. And for the new circle, we need to apply the translation. So that's plus 4 minus 3. These two cancel out and make 0. And 3 minus 3 makes 0. So this is the new center of the image. So being that we have a new center, it's just x squared plus y squared, and that's equal to the same radius square of 9. So under this translation, this is the new equation for the image of a circle. So I want to show you at this point in time how we end up going from the distance formula and going to the center radius form of a circle. So we already know that the distance is equal to the square root of the change of x squared plus the change of y squared. And we know that r is also equal to the square root of the change of x squared plus the change of y squared. If I square the radius, and I square this side, I end up with r squared is equal to x minus, I'm going to replace this value with h squared plus y minus, I'm going to replace this value with k squared. And here we have the center radius form for a circle. That's how we derived this equation. It stems from the distance formula. Okay, so it's not times 2, it's squared. Just be careful there. So completing the square for a circle equations, it can only be done on equations that have the same coefficients for the squared terms. And that's all you should be working with at this stage in the game. We're going to use this form from an expanded form. So you'll be given something that looks like this. You need to get the like variables together and perform completing the square, which you will see in a minute. So here's what it looks like. First step is to group the same variables together and put the constant on the other side of the equal sign. Very similar to what we did when you solved for quadratic equations using completing the square last year. So I'm going to group x squared with 8x, leave a spot open. I'm going to group y squared with minus 2y, and I'm going to put 8 on the other side. So that's a negative 8. So we're going to look at this middle term here. We're going to take 1/2 of it, which is 4, and square it. So that makes 16. I'm going to add 16 here. I'm also going to add 16 here. Now we're going to take 1/2 of negative 2, which is right here, the coefficient of the y term, which makes a negative 1, and square that, and we get plus 1, and we have to add that to the other side of the equation as well. Okay, so I have two perfect square trinomials. I can go ahead and factor those as one factor. So factors of 16 that add up to a negative 8 is x minus 4 squared, plus factors of 1 that add up to a negative 2 is y minus 1 squared, is equal to a sum of negative 8, 16, and 1 is 9. So the center is 4, 1, and the radius is equal to 3. Here's my equation in center radius form, and here are the values that we're looking for, center and radius. Okay, when there's a coefficient greater than 1, all we do is divide out that number, and since these two are the same, I'm going to divide it out all the way across this equation. So we end up with x squared plus y squared minus 2x plus 3y minus 6 is equal to 0. Now we need to group similar variables together. So let's start with the x's. X squared minus 2x. Leave a spot open for the third term. Plus y squared plus 3y. Leave a spot for the third term. Is equal to a positive 6 when you add 6 to both sides. So take 1/2 of negative 2, this term right here. So the coefficient of that term, that is, negative 2 divided in half is a negative 1 squares plus 1. What you do to one side, you also have to do to the other, so you're going to add 1 to the 6. And then you're going to look at the coefficient of y, which is a positive 3. Take 1/2 of that, that's 3/2, and square it. That's plus 9/4. We're going to add that to the 7 over here. So I have my perfect square trinomials. Write it in terms of one factor, so x minus 1 squared plus y plus 3 halves square is equal to the sum of 6 and 1 and 9/4 is 37/9. Your calculator does that for you. Don't worry about having to do that by hand. So don't get nervous. Now we can identify the center as 1 comma negative 3 halves. So that's negative 1.5 if you want to write that. And the radius is equal to the square root of 37/3. So now your assignment that's associated with this lesson will be provided to you the next time I see you in class.